Welcome to Ask and Learn.
You have a force that you have to calculate in part A. And remember, force is just the negative derivative with respect to the position coordinate, in this case r, of the potential. Okay, so it's negative du dr. So for the Yukawa potential, it would be the negative of the derivative with respect to r of negative u naught r naught over r times e to the minus r over r naught. We can pull out the constants to the left-hand side, and multiplying by that negative 1, you have negative u naught r naught times d dr of e to the negative r over r naught over r. Okay, and so to solve this, we use the product rule. So what we do is we take this constant, we take one term constant and multiply that by the derivative of the other term and add it to the other situation, the counterpart for the other term. Okay, so what you have here is, let's look at this one, e to the minus r over r naught times derivative of 1 over r. And so that's r squared, or negative r squared. And to that we add 1 over r times the derivative of e to the minus r for r naught, which is actually just minus 1 over r naught. So we plug that in there. And what we get is u naught times r naught over r. And there are negative signs in both of them, times e to the minus r over r naught, that's common too, times 1 over r plus 1 over r naught. And that is the force due to the Yukawa potential. And now in part B, we want the ratio, two different r's for this force. And so f at 3 r naught to f at r naught. So that would be, so one thing we can do is immediately get rid of the constants. U naught, r naught drop out because they're constants. And what we're left with is e to the minus 3 r naught over r naught. So that's just 3 minus 3 over 3 r naught, that's r, times 1 over r plus r naught. So 1 over 3 r naught plus 1 over r naught. Divided by e to the minus r naught over r naught, so e to the minus 1 over r naught times 1 over r naught plus 1 over r naught. Okay, and so the r naughts cancel, and what happens with the e's is that you pull it down lower, you get e to the minus 3 minus plus 1, or plus 1, times 1 plus 3 over 3 r naught divided by 2 over r naught. And so this is e to the minus 2 times times 4 over 3 r naught, and we pull up this denominator to the top, and what we get is times r naught over 2, and so the r naughts cancel, the 2's, you have 2 left here and 1 left here, and so we get 2 over, whoops, I think I missed a factor of 3 here, 1 over 3, yep. So we get 2 over 3 times 3, so 2 over 9 times e to the negative 2. And so if you plug this in, this is approximately 0.03. Okay, in part C, we have a different u, so this would be negative ddr of minus c over r. And so this would be, the derivative would just be c times 1 over r squared minus and minus minus is plus, but there's a negative outside of it too, so force comes out to be negative c over r squared. Therefore, the ratio here, which is a lot simpler, is just 1 over 3 r naught squared over 1 over r naught squared, and this is 1 over 9th, which is approximately 0.11. So Yukawa force, therefore, Yukawa ratio is 0.03. Electrostatic ratio, electrostatic force ratio is 0.11. So Yukawa force is the ratio of Yukawa forces when you triple the radius is a lot lower than the ratio of electrostatic forces when you triple the radius. So Yukawa therefore is a short range force, and that's it.